Evaluating trigonometric limits, there are two theorems that we need to know. The first one is limit of sine x over x as x approaches 0 equals 1. And the next theorem is limit 1 minus cosine of x divided by x as x approaches 0 equals 0. Basically, the second one is like a version of the first. So suppose we are trying to find the limit of 1 minus cosine of x over x as x approaches 0. Obviously, when you make a substitution, you get 1 minus 1 over 0, which is really 0 over 0. That tells us that we can try some techniques to find the limit. And one technique that we could use is multiply and divide with 1 plus cosine of x. And the reason why we do that is because 1 minus cosine of x times 1 plus cosine of x is 1 squared minus cosine squared of x, which is 1 minus cosine squared of x, which is sine squared of x. So limit as x approaches 0 sine squared of x over x times 1 plus cosine of x. Now we know that sine x over x is 1. So sine squared of x, we split it into sine x times sine x. So there is an x in the denominator. So one of those sine of x's can be divided by x. And the reason why I'm making this sort of rearrangement of terms is to make sure that I can use the theorem limit of sine x over x as x approaches 0 equals 1. So this makes it a 1. We have another sine x. If I could have a sine x in the denominator, then again I could use the same theorem. So I multiply the numerator with x, I multiply the denominator with an x. So that makes it sine x over x, but of course you multiply the sine x with an x. And of course we have a 1 plus cosine of x in the denominator. Now when I apply limits, sine x over x approaches 1, x approaches 0, sine x over x approaches 1, so finally I have 0. So that's how this theorem works. Basically, I don't have to do all the work. The next time I see a limit of 1 minus cosine of x divided by x as x approaches 0, that's equal to 0. Just like sine x over x as x approaches 0 is 1, we can use limit of 1 minus cosine of x divided by x as x approaches 0 equals 0. So now let's look at problems. Let's look at the first one. 1 minus cosine of x over 2x as x approaches 0. Now the minute you see a 1 minus cosine of x and an x in the denominator and as x approaches 0, then we have to remember the theorem. The theorem says, so we rearrange the terms so we can use the theorem. So we have an extra 2 in the denominator. So I write it as 1 over 2 times, we have an 1 minus cosine of x in the numerator, and then of course the x in the denominator. So the 2 is here and the x is here. I'm rearranging terms so I can use the theorem that I have discussed above. So we have limit as x approaches 0 of half times limit as x approaches 0 of 1 minus cosine of x over x. Now limit of a constant is the same thing, which is half times limit of 1 minus cosine of x over x as x approaches 0. So this is equal to 0. So that's equal to 0. Now limit of 1 minus cosine 2x over 3x. So that's the second problem. Remember, we are looking for the same pattern. And what's our pattern? Limit of cosine of 1 minus cosine of 2x divided by, I want to see a 2x in the denominator. And if x approaches 0, I could make that equal to a 1 because that's what the theorem says. So now limit as x approaches 0 1 minus cosine of 2x. I have a 3. I'm going to move that away from the expression. So we have like 3x is really 3 times x. So I keep that separate. And then I have an x. But in order to use the theorem, I need a 2 here. So I multiply and divide with a 2. So now we have limit as x approaches 0, 1/3. Remember that 1/3 remains as 1/3 times 2 times 1 minus cosine of 2x over 2x. Now this whole expression approaches 0 as x approaches 0. If x approaches 0, 2x also approaches 0, so we can use the theorem. Now the rest is the 2 times 1/3, which is really 2/3. So 2/3 times 0 is 0. Now let's look at the next one, and you get the idea now. If you see a 5x here, as of course make sure x is approaching 0, we need to see a 5x in the denominator as well. So let's rearrange terms. So limit as x approaches 0, I move the 2 away from the 2x so we write it as 2 times x. And then I have a 1 minus cosine of 5x over x. Remember the 2x is 2 times x. But now I need a 5, so I multiply the denominator with a 5 and I multiply the numerator with a 5. So if I take limits as x approaches 0, this entire term goes to 0. Now whatever this is, which is 5/2, it really doesn't matter because everything is going to become 0. Now the next one, very similar. We have limit as x approaches 0, 1 minus cosine of x over 2 divided by, I have an x. What I need is exactly this term. How I get that is dividing by 2, dividing x by 2 and multiplying x by 2. So now let's look at this. Limit as x approaches 0, all this approaches 0. So I have 2 in the denominator, so that's a constant. So half times 0, which is equal to 0. So one last problem. The two theorems are limit sin x over x as x approaches 0 equals 1 and limit 1 minus cosine of x over x as x approaches 0 equals 1. So we almost see both the theorems sitting here. So we have limit as x approaches 0. We're going to split the x squared and write it as x times x. So we have sin x times 1 minus cosine of x divided by x times x. So clearly when we take the limit, we have sin x over x as x approaches 0 equals 1. So if I take the limit, that becomes 1. When I take the limit of this, that becomes 0. So this is equal to 1 times 0, which is equal to 0.